Okay, you guys, check out this question. Ascending my 60-foot tall apartment complex, I hurled my calculator upwards at an initial velocity of 48 feet per second. And after 2 seconds, here is the height of my calculator. I'm sorry. Tonight, I can't prove this to you. You give me 6 more weeks, I'll prove to you that equation is accurate. It's just that, number one, this neglects resistance from air resistance. Number two, the 64 came from the initial height. The 48 came from the initial velocity. The negative 16 came from gravity. Well, half the acceleration due to the gravitational pull for this particular planet, which is approximately 32 feet per second squared, or in metric units, 9.8 approximately meters per second. I can't justify that, Nabil. Give me 6 weeks. I promise you. I'll justify it when I start undoing differentiation, which is called anti-differentiation or integration. So, Nabil, tonight you have to believe me at face value, and I promise you, before the semester's over, I'll prove to you this has to be.
Can you just explain it really quick, and then if we don't understand it, we don't understand it?
If you insist. I think the acceleration due to the gravitational pull on this particular planet is whatever the acceleration is. But acceleration is a rate of change of velocity. So undoing the differentiation process, I think you get this. You don't believe me? Go backwards. Differentiate this and you get that. Oh, I might have a constant. Oh, but that constant will be the initial velocity. And I think the position function, the height function, will let me anti-differentiate, undo the differentiation process again. If you don't believe me, go backwards. Differentiating, 2 gets brought down, gives you this. Plus the initial velocity times t, plus another constant, which is the initial height. I'll be better, Nabil, though, in 6 weeks. I'll be better with that. That's a good reference. I'm glad it makes sense. That's awesome.
Can't you just apply kinematics to it?
What's that?
Can't you just apply kinematics to solve it?
I could. I can even modify everything by saying I will consider air resistance, and I can mathematically modify this equation. But that would take for math 3.
Really?
Yes. Oh, yes. I promise I'll do that.
Oh, I won't be there, though.
Oh, it's the best place to be. Oh, no, I never asked a question.
You didn't use the word C. Yeah. Oh, that's true. He is the cat. C was the difference.
So would you be involved with throwing yourself on?
This is a pretty dark question. That's a human guy.
No, I won't be dangerous like that.
Don't jump! Don't jump!
Thank you. So, can we differentiate? Because, you guys, when it comes to the height function, if I've got y being equal to some position function like a height function, I think when I differentiate, I get the rate of change of height, but the rate of change of height is nothing more than velocity. In fact, if I differentiate a velocity, I think I merely get acceleration. And if I were to differentiate position twice or velocity, I misspoke, position thrice or velocity twice, or just simply acceleration once, then I get the jerk of that particular object at time t. And so for me to find the velocity of my calculator at time t, I guess I should come up with a derivative function. And so I think h prime of t, you guys help me with this, just nothing more than negative 32t plus 48. And now we're going to value h prime at what value t? 0. See, I don't know what it is. No, I'm stuck. I'm stuck. I got to pull out a piece of scratch paper.
Well, I just did the math.
And that's what I'm going to do. I'll just write it out more carefully. I think to find out when my calculator hits the ground, I need to find out when h is equal to 0. But if h is equal to 0, doesn't that tell me 0 is equal to, I don't even remember, is it negative 16t squared? I just made these numbers up out of thin air. Is it plus 48t?
Yes.
Plus 64? Ah, shoot. That's a math D question.
Oh, that's T.
Yeah, that's T.
Oh, what's that?
Now that you can distinguish my T's and my pluses, what do you want to do next?
Factor.
Factor out. Negative 16 and divide both sides by it. Doesn't that give me t squared minus 3t minus 4?
Yep.
Ah, shoot. Whoever made this question up out of thin air made the numbers really nice.
Plus 1.
So t is equal to 4, or t is equal to negative 1. So what really happened is the calculator bounced, right? It bounced, hit the ground.
No.
No. In terms of this physical model, if t is equal to negative 1, that means I'm going back in time that's measured in seconds. There's nothing wrong with what I did mathematically speaking. I just think with this mathematical model, this particular solution has no meaningful interpretation of the problem situation since I'm not going to go back in time. So I think, what's that? No, you got a good point. There's an understood restriction domain that t is going to be posits and going forward in time. And when I stood up there, hurled my calculator, that was exactly when t is equal to 0. Now let's let time run.
Does that mean anything at all? Does that mean anything
To
about
do
like,
square
if
root
we
2
could go
GHL?
back in time?
Huh?
and
It's
it's
like
like,
the.
You know what?
Final
It does
velocity
mean a
is
lot.
the square root of 2
Maybe not going back in
times
time,
gravity.
but what it really means is this.
I haven't done that. Times gravity.
That because this physical phenomenon was a strict domain of t squared to 0, I was able to build a mathematical model that went beyond those constraints. As a matter of fact, with my mathematical model right there, it could be the case that t is equal to 1,000. It is the case that t is equal to 1,000. H is negative, meaning the calculator went to the ground.
yeah.
And so it's just that my mathematical model only has meaningful interpretations when t is positive and h is positive.
I see it.
So it's
So
understood
it's just
restriction.
a model.
It's just a mathematical model with restrictions on both the domain and the range. Oh, by the way, I still haven't answered the question. When did my calculator hit the ground?
4 seconds.
After 4 seconds. So when I plug 4 in for t, I get units. Very nice. Did you guys agree?
It's feet. I should have converted to meters first. Because the 2GH meters.
Okay, I'll read it out loud. A particle's position as it moves along okay, you're right. A line is given by, I'll leave if you don't stop. It's given by this equation, this model. I don't want to waste time, you guys. I made an example up. I just want the numbers to be nice. Anybody?
6t squared and 16
I heard that. So what you're really saying is the velocity function is going to be nothing more than the position function's derivative, which in this particular case is 6t squared minus
6dt
minus 12.
After what time? Is that,
Yeah, when does this particle stop? At what time t does this particle stop?
oh, they just factor.
Factor
No, two.
Equaling it to
2 n.
Yeah, you want it to be equal to 0, right?
2 n.
Yeah, if the
2
zero
n.
factor doesn't matter.
2 n. 2 n. 2 n.
Negative
Negative
1.
1. I like it. Because after all, if I factor out a 6, here's what's left over. And if I factor out that trinomial, so I think at t being equal to 2 or negative 1. I'm just going back in time.
Wait, for that
Yes, I'll wait.
problem, would it be safe to assume that there's the domain of t must be greater than 0?
You know, you got a good point. I wasn't expecting that. I was actually thinking that time's just going to go from negative infinity to infinity.
Oh, really?
I mean, that's what I was thinking. I maybe should have stipulated that. And besides, you guys, for a physicist, what is time? In physics, what is time? So actually, we don't know. If you talk to a theoretical physicist, he will not, or she will not, define time. We don't know what time is. It's like a mathematician who bases everything in set theory. We don't know what a set. Every time I define a set, it leads to a logical contradiction. So I never define a set, even though all of mathematics is determined in terms of sets. What about this question?
S equals 0.
plug in 0 to that.
Plug in 0 for that
Yeah.
in the original equation. You guys, it's too far away. 0 is equal to,
18.
Oh,
I couldn't hear,
2
2t cubed, isn't it?
Minus
3t squared minus 12t plus 18.
Plus what?
That's not what we're trying to.
And so in solving this equation, what would you do?
plug in,
Pull out 2.
uh,
Alright,
Pull out.
no, I'm right.
Pull out.
Can't we just say
Can't you just do
S
the
of-
p cube thing? grouping?
I can use p over q, which is called the rational root theorem. Or rely on math d and factor by grouping. Pull out a,
T squared.
oh, wait. And here's what's left over in red. Ah. And then pull out a, I can hear you. So what color pen you want to use, black or green?
Go black.
Black or green?
Red.
Red. Neither black or green, because what you see
Trick
left over
question.
is exactly what you Well, that's the whole point behind factor by grouping.
It's just not.
Leave me alone. And so I see that 0 is equal to, oh shoot, now there's 2 terms, each of which has a common. Red, binomial factor in common, pull it out. And here's what's left over in blue. Ah, shoot, we're not done. I said we're not done.
T.
T plus square root of 6. T minus square root of 6.
Ooh, very nice. So how many times does for how many times does this particle actually pass a position as s equals 0?
3 times.
3 times. Those particular time values. 3 halves, root 6, negative root 6.
Wait, what does that mean?
That means on a number line. Here's 0. It means initially the position was like 18. It's just that the particle might, go backwards, pass through 0, pass this way, and then go that way again. Something like that. It changed directions.
Is it a remote control airplane? Because I don't get it.
I know, maybe it's a poor question. And I'm not drawing very well. I meant for the particle to be on this number line.
Okay.
When t is equal to 0, its position is at 18 on the number line.
Okay.
It's just that as t increases in time, I might pass through that 0 value repeatedly a few times. Actually, I do those 3 times. It's not a great question. I promise you, you guys, when I talk about anti-differentiation another 6 weeks, we'll revisit this issue, start computing how far we traveled on this number. Right now, I'm just worried about your understanding about velocity being the derivative of position, and acceleration being the second derivative of position. Oh, shoot! I didn't ask that, did I? Let's ask it. Part 4. Determine. Acceleration is a function of time. What do you get? Anybody?
12t minus 6.
12t minus 6. What is acceleration equal to 0?
Minus 1/2.
At t equals positive 1/2. Well, when a is equal to 0. Good, I agree. Yes, I'm so sorry.
I kind of missed that very last question.
Please,
Could you
come back.
briefly explain?
For me to determine the acceleration, maybe I'm not writing enough. I think the acceleration is nothing more than rate of change of velocity. And since my velocity function is right here, I was simply differentiating that velocity function. I brought the 2 down, and it got my 12t minus 6.
Well, is A just known to be
Acceleration.
so?
Thank you. Maybe I said that too fast. I meant to say that A represents the acceleration of the particle over time, which is a derivative velocity. Oh, I'm not on. Ah. So everybody, the total, in other words, lifelong earnings from the sale of copies of the hit single Mathmagic by the group of the derivatives is mathematically modeled. Stop laughing. I wrote this late at night. I typed late at night. I'm a little punchy.
Is that your garage band?
You know, when I was young, I was the lead singer for a rock band, and they let me name the band. I called them Spear. Isn't that a cool name for a band? What's that?
It is pretty.
It's where T of X is measured in thousands of dollars, and X represents the number of years after its initial release. Let's you know I determined T prime of X. Well, that's a very cold question, but I promise you my next question is going to be more meaningful. Let's just coldly differentiate this function. How do I do that? I agree, quotient rule. That gives me an x squared plus 100 times a 100x minus
X squared.
50x squared times 2x all over.
X squared plus 100 squared.
I agree. Oh, but shoot, you guys, when you clean up that numerator, something kind of nice happens, I think. Unless I'm doing too much in my head. I get 100x cubed minus 100x cubed are gone. I think I'm merely left with a term of 10,000x. Tell me if I'm wrong.
You're right.
And let's evaluate t prime of 10. I think t prime of 10 is nothing more than 100,000. All over of, I don't know. Is that 200 squared? Which in this case ends up being 2.5.
Whoa.
Well, just double check my arithmetic. I'm tired.
Hold on, for
Yes.
that last part,
Yes.
how'd you pull the X out?
Which X? You mean upstairs?
Yeah.
I didn't. I replaced X with 10.
Oh.
And 10,000 times 10 is 100,000.
Oh, okay.
Shoot, you guys, what does that represent? So what that T prime of 10 is equal to 2.5? What the heck does that mean?
It's a great question.
That means that at 10 years after they released the single,
Yes.
they made $2.5.
No.
2,500. 2,500.
So say it again more smoothly.
In the 10th year after the single came out, they made $2,500. Or the single made $2,500 in that year.
That's better. Sir, I'm sorry.
Oh,
Is that okay? Seriously.
no. I was thinking, ignore what I said.
I don't
I
get
would
it.
have said 10,000 or tens of thousands.
Oh, gotcha. It's only thousands, right? Can I say it differently, guys? I think the earnings earned in the 11th year is approximately $2,500.
Why not the 10th year?
Because I think, good question. Because I think, no matter what my curve looks like, looks something like this. Here's x equals 10. And I think in red, here's a tangent line to the graph. And I think since t prime of 10 is equal to 2.5, that's the slope of the tangent line at x equals 10. Now, given that that's the slope of the tangent line, I think when I increase 10 by 1 unit to 11, the corresponding increase in the y values on the tangent line is going to be 2.5. It's not the same necessarily as the increase in y values in the blue curve, because once I move from 10 to 11 on the x-axis, I think the corresponding y value in the red line and the blue curve are different. But I do think this particular